Okay, when we run the programs today, they're all going to end the same way. They all end with a p-value. So, if the p-value, which is a probability value, if that comes out less than or equal to your alpha, you're going to make the decision to reject the hoe. So we're not going to be making the graphs and converting to z-scores to see where things land. This is completely different. It's technology. You type in all the same information, but it calculates a probability value. I obviously don't know the formula, or we would be doing it. But the probability value, if it comes out smaller than your alpha, you will reject the hoe. So then the other side of the coin, if the probability comes out greater than alpha, you're going to fail to reject the hoe. Alright, so there's 3 programs. You got your z-test, t-test, and one prop z-test. Z-test is going to be used when we have the large sample, t-test when we have the small samples, and the one prop z-test when we do the proportions. So while the steps are, you still have to rewrite the claim, identify hoe and ha, then we run the program, write down the p-value, and then make our conclusion. So let's look at the first one. Let's see if we can decide. I've got them mixed up here, whether it's a z, a t, or a proportion. So it's the number of years it took a random sample of 32 former smokers to quit permanently is listed. At alpha equals 5%, test the claim that the mean time, there's your clue, it takes smokers to quit smoking permanently is 15 years. So the claim is that the mean time it takes to quit is 15 years. So in this case, the claim is hoe. So the mean not equal to 15 is the ha. Okay. So when we're talking means, you have the choice of z or t. Do you know which case it is here? Why z? Over 30. So the program's name is z-test, because these are all hypothesis testing. Where last chapter they were confidence intervals, so they ended in int, these will end in test. So if you grab your calculator, and I already did the 1-bar stats for you just to save time. Thank you, Mrs. Schwartz. So the 1-bar stats gave out this mean, this S, and this sigma. So you could see all that, and you got to tell me which of these two we're going to use, which is why they're both there. So go to stat, over to tests, the very first one is z-test. You want to be under stats. Then we're going to, for this one example, we're going to write down what all of these lines mean, and then you won't have to do that again. So we'll write down what they mean and what we'll put in. So the very first thing you see is mu0. What do you think that means? Where else have you seen that 0 before? In the hoe. So this is asking for the hoe value. So in this case, what number are we going to put in there? 15. The next one is the sigma. Be careful. Do we actually know the population standard deviation? I mean, it looks, I wrote down population standard deviation because that's what was on the 1-bar stats. But what did I feed 1-bar stats? Did I feed it a population of data or a sample of data? I gave it a sample. Calculator doesn't know that that was only a sample. That's why I wrote both of them down. This does not apply because I put in a sample into 1-bar stats. So we don't have this, so we use the S value as the best estimate for it. So use S if sample, which we have. So our S is 4.288. Next one, self-explanatory, sample mean. Which was 14.83. And his sample size which was 32. Then you see this mu, and then you see not equal to mu0, less than mu0, greater than mu0. Ignore all the symbols there. Just look at the not equal to, less than, and greater than. All of those are the ha signs. So what sign did our ha have in it? Not equal to. Just pick the one that looks exactly like the one you wrote down. So this very last line is your ha sign. Pick the ha to look exactly like you write down. So in this case, we want the not equal to. And then go down to calculate. All kinds of information there. The only number I want you to write down is the p value. It stands for the probability. So our p value is 0.823, approximately. Okay, and now we make our decision off of that. So it's got a really high probability of happening. So I told you up here, if p, and our alpha was 5%, so in this case, p is greater than alpha. So our decision we're going to make is fail to reject the hoe. And I'm running out of room here. Now say something about the claim. So you go back to the poster and finish it up. What do we got? Neef. All right, next one. As part of your study on food consumption habits of teenage males, you randomly select 20 teenage males and ask how many 12-ounce servings of soda they drink per day. The results are listed below, which I took the time to type in for you, gave you mean, S, and sigma. At alpha equals 5%, is there enough evidence to claim that teenage males drink less than 3 12-ounce servings of soda per day? So we were looking for the average number. It doesn't really say average in there, but that's what it is. So the claim is that the average number of servings per day is less than 3.0. Making the claim, haha. The whole will be greater than or equal to 3.0. And I tell you that the population is normally distributed. So I've got means, so that means I'm either doing Z or T. What's the case? Small sample, normally distributed. Which standard deviation, knowing not all of this came off of one var stats, which I didn't write down, which standard deviation applies? S. It's a sample, so again, that's not accurate because I typed in these 20 numbers and this is a random sample of kids, not a population of kids. So we're doing t-test. And I don't think you'll see anything change, so I'm not going to bother writing down all of those values again because they're exactly the same. So let's just see if we can figure out what to put in. So go back to stat, over to tests. T-test is number 2. We want stats. Okay, we got that same mu0, which comes from the hoe. So 3.0 or just 3. X bar, so things are different order, but X bar is up here from my 1 var stats, 2.785. S, 0.828. N was 20. And now the ha sign. Which way is the ha pointing?
Left.
To the left. So that's that middle one here. Just look at the way it's pointing. And then down to calculate.
What does draw do?
I think it just sketches a graph. You could try it if you want. And the only number we want on there is the P. So the probability, 0.130. How is P comparing to alpha? Because that's how we make our decision from the top here. P is greater than alpha again. So that means we will fail to reject the HO. Using the chart, neat this time. Okay, 34. An Alabama politician claims that the mean annual salary for engineering majors in Alabama is at least the national mean of $69,000. That the mean annual salary is at least $69,000. How? Huh? Oh, I forgot to change it. This is not 34 anymore. I got rid of it. I wanted to change this one. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 engineering majors. At 3%, test the politician's claim. So because it's mean, is this a Z or T?
T.
Small, right? I can run one of our stats. I forgot to do it. Didn't write down the mean and standard deviation, but I could find them easy enough. But there's still enough information here. With a small sample, what's the second piece of information that has to be given to you in order to continue on? Normally distributed. Did I write that anywhere? No. Not given normal with a small sample. It only has to be given with a small sample. If it's 30 or more, it doesn't have to say it's normal. You can automatically do it. That's that central limit there. Not given as normal, so you cannot continue on to make an accurate hypothesis test. So
If it's a small sample, it's always going to be T. But if it's
no, if it's a small sample from previous studies, it is known that the standard deviation is this. The population standard deviation is given with a small sample, then it's a Z.
Okay.
So a small sample can be Z or T. It all depends, after it's given normal, it all depends on which one of these is given. But again, it would have to tell you, it is known that the population standard deviation is this. Then you do a Z. I don't have one of those on here. So not given, so can't continue. Not enough information. What do we want to say here? Not given, normal, can't do. Can't test. Alright, number 4. Made this one completely up. This is not based off anybody's data, but me making up a problem. Less than 60% of Americans are overweight. Sample 35 people. 58% are overweight. Tested at 1%. Alright, so here's the claim. Let's see, we got claim. 60% of Americans are less than 60%. So first of all, what's my symbol I'm using? P, because it's a percentage. So P is less than 0.60. Making the claim the HA. The HO is greater than or equal to 60%. But remember, this section you have to check to make sure that it's normal. It can't just be 30 or more. So we got to check for normal. God, I don't think I did this. I hope these come out big enough. So we'll check 35 times 0.60 21. And then 35 times 0.40, 14. So they're both okay because what was the magic number there? 5. All right, so we continue on. The test we're going to run, because it's proportions, it's called one prop Z test. Let's see what's in there. Five is the test. So P0, there's not much here. What do you think that is? That's the whole percentage. Whole percent as a decimal. So our whole has 0.60 in it. Then it wants X and N. What do you think X represents? Jimmer? It is the number of successes. Did I tell you how many successes? No, I gave you the percent of successes. So this has to be the number of successes. So out of my 35 people, how many were overweight? How do I calculate that? You just multiply by your percentage, and it has to be a whole number. So you can do that right on this line right here. Watch. I can put in 35. Oh, we already did this, didn't we? Oh, no. Times 0.58. It's saying 20.3. What do you think is going to happen here when I say I had 20.3 successes? It's going to have an issue with that. So how many successes did I have? 20. Regular rounding, it's got to stay as close to 58, the true 58% as I can. So this isn't minimum sample size, it's how many successes did I have. So we're going to go back up, make that 20. So round normally there. And then N is your sample size, which was 35. And then it's the ha sign again. And our ha is pointing to the left, so that's the middle one. So we're good to go there. And then down to calculate. And we want the P, not the P hat. So P is 0.365. Compare that to alpha. Alpha was 1%. So we got another greater than. So fail to reject the hoe again. And that would be a neat. Not enough evidence to say that was true. Okay, I have a worksheet for you.